AOPS Volume 1 The Basics number 32. 4 pounds of onions cost the same as 2 pounds of string beans. At the same time, 1 pound of string beans costs 3 times as much as a pound of potatoes, while 1 pound of onion costs 4 cents less than 2 pounds of potatoes. What is the total cost without tax? 1 pound of each vegetable. So there is a lot going on here, but if we simplify things down by assuming some quantities, we should be able to simplify it down into some simple arithmetic. So let us suppose that the price of 1 pound of onions in cents, note this is in cents, so let's put the cents there, is X cents. And the cents per pound of a string bean, so string bean will be Y, and the cents for 1 pound of potatoes is going to be Z. So with this, we can begin to utilize the information that's given to us. 4 pounds of onions cost the same as 2 pounds of string beans. Furthermore, at the same time, 1 pound of string beans, so Y, must cost 3 times as much as a potato. So 3Z. While 1 pound of onions cost 4 cents less than 2 pounds of potatoes. So that means that 1 pound of onions must cost 4 cents less than 2 pounds of potatoes, minus 4. And notice right here, last time when I first did this, I did trip up on this due to incorrectly assuming my quantities. But remember, we assumed each unit of measure in pounds per cent in cents. It's not in dollars, so we don't write 4 cents as 0.04. So that is just a thing to look out for because that is what I did the first time. So with these three system of equations, we can just solve the variables. Since we have 3 equations to solve 3 variables, we can simplify this equation first to get 2x is equal to y. Therefore, y must be equal to 2x, which is equal to 3z. Hence, 1 pound of onions must be 3 over 2 the price of a pound of potatoes. And we can substitute that for x in this equation to get 3 over 2z minus 2z is equal to negative 4. I just rearranged the equation a little bit. And from this, 3 over 2 is nothing more but 1.5 minus 2 is negative 0.5z is equal to negative 4. So z must be equal to 40 over 5, which is equal to 8, meaning that a potato costs 8 cents, not $8. Remember how we assumed each quantity. So with z out of the way, we can find the other variables. So we can find x first of all. X must be equal to 2 times 8, 16 minus 4, which is 12. So 1 pound of onions cost 12 cents. And from this equation, we can solve for y, meaning that 1 pound of string beans must be twice the amount for onions, which is 24 cents. So y will be 24. And now we can answer the question, 1 pound of each vegetable, how much it will cost. So 1 pound of each vegetable in cents, well, we already solved it for each individually. So 1 pound of each vegetable will be 12 plus 24 plus 8, which is equal to a grand total of 44 cents, the solution to our question.